Good morning, everyone. I hope you all are doing good. Welcome to my physics class. Now, today we will start a new topic, that is electric potential energy. Before this, we have done the concept of potential, equipotential surfaces. Now, in this electric potential energy, basically, electric potential energy, this is of a system of charges, many number of charges can be there, is defined as amount of work done in bringing the various charges to their respective positions from infinite distance apart. Firstly, we understand what is the meaning. Electric potential energy of a system of charges, like we have number of charges. They are situated somewhere at infinite distance. Then what we have to do, so whatever work will be done to move it at some finite distance to the respective positions from infinite separation. So whatever work will be done, that will be expressed as electric potential energy. So it means, in simple terms, this is basically work required to be done to move a charge from one point to another. So first of all, we will explain it for a system of two charges. Let me take potential energy of a system of two charges. Let two charges are there. Suppose a point charge Q1 is at point P1. Right? This is at point P1. Now, let we have taken this charge at P1, or we have taken it somewhere from infinity. Suppose this is an infinite point. Initially, we have brought this charge Q1 from infinite separation to P1. So, in that particular case, as we will say, no work will be done in moving charge Q1 from infinity to P1. What does it mean? Why the work done is not there? Why work is not there? Reason being, because at this point there is no field present. There is no effect of any other field. So in that particular case, as there is no field, so there will be no potential at this point. So work done will be 0. It is entering in field free area. Now let me take another point. Q2 is at infinite distance. Let we are bringing it to point P2. We have to bring from infinite distance to point P2. So correspondingly, let this separation distance between two charges Q1 and Q2 will be R. You can take it as R12 also. As the separation distance R, this can also be R12. In both the ways we can take. It is symbolic representation only. So first of all, now what point we have to understand here, as Q2 is brought in a region where original electric field of Q1 is present. So due to this, potential will be present. So you can say electric potential at P2 due to Q1 at P1. Electric potential at P2 due to charge at P1. So what will be that? This will be K Q1 upon R. At point P2, what is the potential of charge Q1? This is K Q1 by R. And now if Q2 is brought, from infinity to point P2, so now what will be the work done? Work done will be potential multiplied by charge. As the definition we have done, potential is work done per unit charge. So now substitute the value K Q1 by R into Q2. This work done is stored as the potential energy of the system, whatever total work is done. So this work done is stored as potential energy of the system. So total in work done will be, total potential energy will be W1 plus W2, as W1 is 0 and W2 will be KQ1 Q2 by R. So potential energy, that will be simply under the influence of only charge Q1. So it will be KQ1 Q2 by R. This is the expression for potential energy of system of two charges. Now, next we are taking potential energy of a system of three charges. Again, for it, we will consider that Q1, Q2, Q3 are the charges located somewhere at infinite distance. Let Q1 is brought at point P. So let initially Q1 is brought at point P. So it is entering in a field free area. There is no potential present. So work done to move Q1 from infinity to P is, that will be 0. Initially no potential, no region is present here. So it is in the field free region. Therefore work done will be 0. Now let me take this Q2 charge. Let it be brought to point Q. Then let this separation distance is R12. So work done to move charge Q2 from infinity to Q. This will be, so there is the influence of this potential only. So here you can write it as 1 by 4 pi epsilon naught Q1 by, what is the separation distance? I have taken it as R12 into which charge has to be brought? Q2. So the work done will be charge multiplied by potential of Q1. Now let this charge Q3, this has to bring to point R such that this distance PR is R13 and RQ is R23. So now work done to bring Q3 at point P3, obviously from infinity. So here, as Q3 is coming in the field of, in the potential region of first charge as well as in potential region of second charge. This is the main point. It is in the influence of first charge Q1 as well as in the influence of second charge. So potential is due to both the charges. Now put the values. Q3, this is potential is 1 by 4 pi epsilon naught and 3 and 1. See, 3 and 1. The separation distance is R13. So it will be Q3 Q1 by R13 plus 1 by 4 pi epsilon naught Q3. Now potential of Q2 you are taking, so the separation distance is R23. So here you will write Q2 upon R23. So let this is equation 3. So we have initially for moving charge Q1 to point P, no work done. Q2 to point Q, capital Q, then some work is done, that is under the influence of charge Q1. When Q3 is entering in the region where potential due to first and second are present, so the work done will be this way. So now what is the total work done? Total work done, this is W1 plus W2 plus W3. It is 0 plus 1 by 4 pi epsilon naught Q1 by R12 Q2 plus 1 by 4 pi epsilon naught Q1 Q3 by R13 plus 1 by 4 pi epsilon naught Q3 Q2 by R23. So this is basically the final result. So potential energy of a system of 3 charges we have taken in terms of work done. You can represent it by U also, that is having the same. Now, as we have calculated potential energy of a system of 2 charges, system of 3 charges, there can be generalization up to n charges. So, if we take, let Q1 charge is brought to point P1 and Q2 charge is brought to point P2, Q3 charge is brought to point P3, Q4 charge is brought to point P4 and Qn is at Pn. N number of charges can be there. This can be the generalization point. So what will be the total work done? Let the distance between these two is R12, R13, R14 and R1n. Second thing, the separation distance between Q2, Q3, Q2, Q4, Q2, Qn. It means all are influencing each other. Then we have to consider all these points. So first of all, let me consider this point. This is R23. This distance is R34. And likewise, this can be R4n. Multiple distances can be there. So simple, if we'll take that, if Q1 is brought at point P1 where no charge was present, so no work was done. Initially, no work was done in bringing a charge Q1 at point P1. Secondly, when Q2 charge is brought somewhere from infinity we have brought it at point P2. Then in that case, in the similar we have done in the earlier case, V1 into Q2. This was K Q1 Q2 by R12. Similarly, work done to move a charge Q3 at point P3. Again, we are taking it from infinity distance. So in that case, now it is coming in the influence of Q1 and Q2. So it will be Q1 Q3 plus V1 Q3 plus this will be V2 Q3 because Q3 is coming in the influential region of Q1 and Q2. So directly, as we have done earlier, directly we can use the result Q1 Q3 by R13 plus K Q2 Q3 by R23. Now, work done to move Q4 to point P4, obviously from infinity. So it will be coming, Q4 is coming in the influence of Q1, Q2 and Q3. So V1 into Q4 plus V2 into Q4 plus V3 into Q4. So what will be the value? K Q1 Q4 by distance separation R14. You can just relate from here. Plus K Q2 Q4 upon R24 plus K Q3 Q4 upon R34. Here we need to write suffix because then we cannot simply take the separation distance as same because they are at different position. That's why we are using suffix here. So it means this is for 4 charges. So if we just take total work done, this will be W1, work done first, second, third and 4. So then we have to add all these values. Now be careful while writing because we have to add all these values. This 1, 2, 3, 4. So let me put the value. Work done will be 0 plus W2 is, this is your K Q1 Q2 by R12. W2 we have written here. Then W3 consisting of 2 terms, Q1 K Q1 Q3 by R13, plus K Q2 Q3 by R23 plus K Q1 Q4 by R14 plus K Q2 Q4 by R24 plus K Q3 Q4 by R34. See, in this result, as if we take, now if we have to consider 5 charges, 6 charges, n charges, then we have to generalize the result. We have to take in terms of nth particle, nth charge, we have to find this equation. So what you can write it as, now see, if I will put summation for this, just I am writing the formula, then I am explaining why I am writing like this. This can be written as K can be taken common, then Qi Qj upon separation distance Rij. Like, then summation limit will be for, this is for limit I as well as j, where I is varying from 1 to n and j is varying from 1 to n, provided j is not equal to I. This is an important point. Why we are taking this point? I have taken K common, then Qi Qj upon Qij, where summation as 2I and j suffix are variables, so we have taken summation of both. Now what is the meaning of this? So let me take, if we are taking from this relation, if I am taking, suppose for this result, if I is equal to 1 and j is equal to 2. So you are getting I1, that is Q1, you will get Q1, Q2. And if we take I is equal to 2 and j is equal to 1, then again you will get product as Q2, Q1. Same effect. That's why we have taken the value should not be equal. Second thing, when we are taking all the values, then the factor will be repeating. Each factor will be repeating. So that's why here in this expression we will take half. As when we are taking the values of I and j, so in that particular case, it means I is not equal to j, it means simultaneously this cannot be 2, 2. Suppose ji is 2, j is 2, I is 3, j is 3. That cannot be possible because a charge cannot influence itself. But what is the meaning of this example which I have quoted here? That if I is 1 and j is 2, these are two different values, but it is Q1, Q2. And now in the next step, if I is 2 and j is 1, this is Q2, Q1, one in the same product. It means when substituting, when taking the different parameters, these terms are repeated. So each Q1 is influencing Q2, Q2 is influencing Q1, but we have to consider only one effect. Like this, see, as Q1 has effect on Q2, Q2 is also effect on Q1, one in the same point. We will not write it twice. Q1 has influence on 3 charge, Q3 has influence on Q1, but we will write it single time. So that's why we will write here half. This is important point. This may confuse you. Why half has been taken? I will just write it here so that you will not confuse. Factor half is taken because in summation, we count each pair of charges, twice. So this is for understanding. This part is not required. This is for your understanding, and for the system of n charges, this is itself sufficient. So see, we have covered this particular topic, and corresponding to this topic we have discussed many So we have done potential energy of system of 2 charges, 3 charges and n charges. Although this concept of potential energy is used in numericals, but since 3-4 years, then 2 or 3 mark question can be out of these 3 cases. So practice it by writing. Don't leave this topic. Initially you think that these topics are just for discussions only. No, you have to practice it by writing for 2 particle system, 3 particle system and n particle system. Any question can be asked in the board exam. Now, next, as we have taken this concept of potential energy without external field, we have taken that when Q1 charge is brought, there was no external field was present. But now, in the next topic, in the next point, what we are taking here, that we will find right here, potential energy in an external field. We will discuss it only for system of 2 charges. Now consider a charge Q1. Let the charge, suppose here we are taking any point where the influence field is there due to this point. Maybe the charge is present. Somewhere charge is present and the field will be present due to this. Let charge Q1 from infinite space is brought within this field, influence region. Let the distance from this point is R1. So correspondingly, potential at this point is VR1. So consider Q1 is brought in external field from infinity. We have brought it from infinity. So what will be the work done? In the initial derivations, we have taken work done was 0. Why? Because there was no field. There was field free region where charge Q1 is coming. Now it is coming in a region where external field is present. So it will be Q1 multiplied by potential. Now let me take another charge Q2. Now Q2 charge, let me brought it from infinity at this point, and the distance from this point is, let it be R2. This is, so correspondingly potential for this is coming in the potential region of initial charge present here. So if Q2 is brought in the field of Q1 and in external field, both the effect will be there. Field of Q1, that means field of Q1 and field of this external part. So what will be the work done? This will be equal to Q2 into VR2. Why? Because of external field. And due to Q1, this will be K Q1 Q2 by R1 2. So that's it. Now just we have to sum it up because it is for 2 charges. This is W. Total work done will be W1 plus W2. So simply you are adding. This is also an important part. So this is potential energy in an external field that we have discussed it for system of 2 charges. Now you can generalize it for n number of charges. So this concept of potential energy is very important from numerical point of view. So you have to give it a writing practice, and then you will be ready for discussion of numerical section for this. So thank you. Keep revising, keep enjoying your work. Have a nice day.